Just as I thought that my collection of robots couldn't get any bigger, I got this. This is precisely what we're going to talk about in this video. Hey guys, some of you probably know that I make robots for a living. Some of them are probably much bigger than these, and that, on top of it, is UltraArm P340, which I covered in the video that is visible in the corner right now. Elephant Robotics has sent me an email and said, like, look, we've got something special for you. And that something special is the base, not just for this robotic arm, but for many others. And as it happened, I couldn't really hide my excitement because we've got a much bigger platform at work. And I couldn't help but just compare one to another and figure out, is it something that can actually get you into robotics at all? For the last couple of weeks, everyone at work was really stoked about ERFlex, a mobile robotics platform that is able to traverse the distance autonomously and perform different tasks using its robotic arm. And it's really fun to see it in action. And while a dedicated team of engineers and labmen is trying to figure out how to use ERFlex for industrial purposes, I was doing pretty much the same with myAGV 2023, because this thing isn't easy at all. Just like professional platforms for industrial settings, myAGV 2023 is a modular design, which means you can pick the modules you like and construct a robot that's going to be the most suited for your scenario, including different selections of arms, because it supports most of the arms from the Elephant Robotics lineup, and additional kits that allow this platform to move around, look around, and find its way around the environment. And since it's available with Raspberry Pi and the Jetson Nano platform, I decided to make my life even harder. I don't know why, but I've done that. And I've picked Jetson Nano, mostly because I haven't used that before and I always wanted to try one out. After all, Jetson Nano is also quite visible in robotic space, and I was very eager to get my hands on it. Overall, it's all good and fancy, but you'll have to pay just over £1,000 to get the platform alone. On top of that, you'll have to probably figure out what robotics arm would you like to get, which might top up to a hefty bill to pay. However, this is nothing compared to industrial robots that I'm working with at work, because those machines, they often cost more than £100,000 each, and this is not something you would feel confident start experimenting with, especially that you can damage those things if you're not careful. So overall, investing in a platform like this is less expensive and it will get you started and hopefully will let you transition from a hobbyist grade equipment and hardware into a more industrial setting. And while these concepts aren't new in the industrial settings, I only just started to see the drive for those solutions in various industries, so being familiar with the concepts might just give you the edge over the competition in landing a job in the industry. And I know it's easy to look at something like MyBlocky and scratch your head thinking like, how's that gonna help me to transition to a professional setting in testing robotic arms, mobile platform and everything? But truth be told, the same concepts apply to big and expensive robots in which you can use something like Scratch-alike programming to experiment with the robot before you actually dive into the documentation and start integrating serious robots into a serious workflow. So don't be discouraged by this, because the transfer of knowledge is much more efficient than you think. But enough about how robots like this help you to get a job in the industry. We have a big robot and a robotic arm on top of it to talk about. So I'll tell you everything you need to know to kind of get started and what's interesting about this robot and where things get a little bit hard. As I said before, you'll have to consider what robot you actually are getting, because you can add a LiDAR platform, support for the arms, additional displays and cameras, or even just a bucket to help you carry stuff from A to B. But once you decide on that, pay the bill and receive a big crate with the item, you can actually get it out and start playing. So what I've got is a Jetson Nano based platform, myAGV 2023, which supports variety of different arms. And since I already had UltraArm P340, that was the adapter they've sent to me so I could integrate the arm on top of that platform. The job was relatively simple. They sent a small document that I followed with a couple of steps in showing me how to mount the arm on top of the mobile platform, including a couple of screws. And that was pretty much it. On top of that, I had like 2 line instructions on how to use Python to control the arm directly from the Jetson Nano inside of the robot. If you take a closer look at the robot itself, you'll quickly notice that there is much going on. First of all, we have Omni wheels, which means this robot can move in different directions, including sideways. And that's exciting because the agility of a platform enables you to manipulate objects much better. And since it's equipped in this case with the P340, it will also support attachments that go on top of the P340. Right now I have fitted the pneumatic picker, but I also have plotter and laser engraver. And trust me, I did not want to run with a laser engraver not knowing what I'm doing, because I would end up probably with burning marks all over my floor. At the front of the robot we have 8 megapixel camera, and this is your basic vision kit. You can get additional stereoscopic cameras if you would like, but that's the camera that you get with it. Under the mounting platform you also have LiDAR, which provides you with ability to map your surroundings and autonomously travel around your room or platform or wherever you're doing those things. Now, in terms of a travel, we have individually driven Omni wheels, and addition to that, the platform itself is self-leveling. It has additional motor to control how the robot is positioned. This means that you get a pretty decent mobility with it, and the robot can even travel over small obstacles, which isn't usually associated with Omni wheels. On both sides of the robot we have additional pockets, and here comes a very interesting concept in which in one you can add extra battery to extend the battery life of this robot. I think by default you get around 1 to 2 hours depending on how intense tasks you're performing on Jetson Nano, and those batteries will also be charged once inside of the pocket. And the other pocket is also exciting because it actually supports a pump, which means I can put the pump in, keep it securely stored, and connect it via special socket inside to the Jetson Nano. I no longer have to drag the cable all the way to my arm. I can control accessories from the myAGV 2023 level. Super exciting. At the back we have a programmable RGB light in case you want to program a status of the robot, and the interface which involves the RJ45 for the internet, HDMI port out, 2 USB ports, and the GPIO header that contains I think 16 different pins. There is a pass-through for power that you can power, in this case, my UltraArm, and obviously a power button. It was quite fun to have it shipped to work and show off to all the engineers in there, because everyone was kind of excited to see it and to see it in action. I haven't looked inside, but I do have a Jetson Nano version which comes with a 4 GB of RAM and 4-core CPU clocked at 1.43 GHz each. But where the Jetson Nano platform shines is support for the CUDA core, which makes all the vision calculations a little bit faster, and this board comes with 128 CUDA cores to solve all the graphical problems, and I think that is the more efficient version than the Raspberry Pi. So if you're selecting your robot and you want to focus on the autonomous driving, probably Jetson Nano is the version you want to go with. But if you are looking to save some money, you can get the basic version with the Raspberry Pi inside for £750. It is shipped with Linux installed on it, in this case Ubuntu, with pre-installed software that allows you to control pretty much everything that is included in the package. And we have the Elephant Robotics My Suite, which is responsible for flashing things and setting up the parameters. We have a ROS, Robot Operating System, ROS2, and we have testing utilities to diagnose and try things out. So everything was pretty much new to me, so I embarked on a journey of learning how to use this platform, and I have some tips for you. First, I needed to put my arm on top of it and connect everything. Now, this mobile platform allows you to carry a load of 5 kilos, which is more than this arm weights and more that it can lift, so I had absolutely no problems mounting it and driving around. Didn't cause any slowdown. It was just working as expected. To get things started, you'll need an additional display, a mouse and a keyboard, because you'll have to hook up to the Jetson Nano at the back. Now there's an HDMI out port to which you can connect the display, mouse, keyboard, and set access to Wi-Fi. You can also do it via Ethernet, but in my attempts to connect, I found that the Ethernet port was already pre-configured with an IP range that wasn't suited in mind and caused a conflict, so I needed to get inside the Linux, reconfigure that before I could use the port. Obviously, because it's a mobile platform, you want to have as little cables as possible, so I quickly switched over to Wi-Fi, so I could drive this around without dragging a cable behind it, and enabled VNC. And in here I came across a couple of issues. First of all, the default password for everything, the root password, is elephant, spelled with a capital E. That will save you some Googling. But my first things to actually fix was to enable the VNC server on the Jetson Nano to run on start. And I'm gonna include all the instructions of how I did it in my article linked in the description, so check it out. You're gonna find it very useful. There is a bug in the shipped version of the Linux on the Jetson Nano, which means that if there is no HDMI screen connected, the desktop environment just doesn't load, which means the VNC doesn't load, which means if I power it off and power it on without screen attached, I can't really access it. And that was obviously annoying, and there are some bug fixes that involves modifying the system and doing a lot of different stuff. They're gonna fix it at some point. Until then, you can get yourself a HDMI dummy, which is this. It costs around £5 on Amazon, and that solves it for you because it fools the Jetson Nano that the screen is connected and everything loads beautifully. According to instructions which I used to connect the arm and try to execute the movements from the Jetson Nano to control my arm, I needed to elevate the permissions. And I wasn't particularly happy about it because something didn't play nice, especially that if I wanted to use my blocky interface to program the arm as well and switch over between Python, I needed to run it as an administrator. And that was kind of annoying, so I've included in the article fix for that as well, so you can elevate it right for the user, and that will help you run everything as normal without extra privileges. Lastly, there was an instance in which once I powered this machine on, it decided to go places. I would strongly recommend you to prevent the robot from going places, especially if you're playing with it on a table, and put it on the blocks or something and suspend it in the air like that, because you don't want to drive it off the table. That would end up in a disaster, especially if the robot isn't equipped in edge detection, and it would just plummet to its certain death considering how heavy it is. So that's another tip from me. In this video, I quickly gave up with the idea of explaining everything about this platform because there is a lot of things. This robot will take you weeks to learn and probably years to master, so be prepared to embark on this journey. You're gonna find it tedious, rewarding, satisfying, and very frustrating at the same time. But there are some things that I figured out thanks to the help from Elephant Robotics, and I was able to get the basic going and talk to the arm and get it moving. So we're gonna talk about that and I'll show you how to set it up. To have very basic control of the robot, of its movement and parameters, and pass the same movements to the arm, you can use myBlocky, which is just a graphical interface for Python. And that's fine. And this is something I would really encourage you to start playing with. Mostly because, yes, it might look like something that would beginners use, but honestly, when you look at automation levels in the industry, they also offer similar solutions to kind of let you play about and see the capabilities of your robot and hardware before you start implementing this into the whatever operating system you're using. Now, this is a very basic way of controlling it, and it won't really give you any ways of autonomous driving. So for that, you'll have to dip your toes in ROS. Robotic operating system is, well, slightly complicated, and at first I've made a big mistake and I wanted to do everything in ROS from the terminal, which was tedious mostly because the documentation for this robot is a little bit lacking, and I'm going to cover that in a moment. So I quickly switched over from playing with ROS to using myAGV UI. At first, I really thought this is just a test tool to kind of see if everything hardware-wise is working, but it's actually just a graphical launcher that allows you to execute everything step by step. And this is what I would recommend you to start with. And we're going to start with taking control of the robot. This is PlayStation-alike controller. It's a Bluetooth controller that is also shipped with a robot and allows you to drive it. You'll need to plug it into USB port and you'll be able to take control of it. But this is where I also kind of run into some problems because the instructions weren't clear enough. Now, you'll find that once you connect everything, the binding on the documentation might not correspond with what you're getting. This is because the select mode, which you need to press, you have to press and hold it for a couple of seconds actually to switch over the light on the controller into a red, and this is where you get into a correct mode to control it, and you'll have basic controls. In order to control the robot from the PlayStation controller, you need to enable LiDAR. So the first thing to do in that graphical interface is to launch the LiDAR and enable that control, followed by selecting either a keyboard method. You'll be able to drive this via keyboard as long as you've got the terminal window open on the computer and focused on. You'll be able to use the keyboard to drive it around and increase the turning speed or just traveling speed. And why are we talking about driving this with a controller while this is autonomous driving clearly? This is because we have to actually help the system to create a map, and that's the next step on our list of things to do. From that graphical interface, you can launch the mapping software. You have an option between the Gmapping cartographer and the 3D mapping. For the 3D mapping, you need a special camera, which isn't the one included in front, so I couldn't use that. I went with Gmapping because it was working fairly okay, and I didn't see any advantage of using other methods, so that's why I used to generate my map. Now, to generate the map, you have to start the software in a map generation mode and drive your robot around until the map has sufficient details. How do you know the map has sufficient details? Well, you don't. This is a practice exercise and you'll see map being populated around it. The more time you're going to spend driving around creating the map, the better it's going to get, and strongly recommend you to take time here. Now, once this is complete, what you have to do is save the newly generated map files. Now, you can do it from the graphical interface and it'll place it in a location visible in the terminal window, but then you have to grab those files and move it to the map location of the ROS, which is used to trigger the launch file. If you're not going to edit anything else, you can simply just stop on moving those two files, the YAML and PGM map files, into correct location. Again, I've indicated that step by step in my written article, so do to check it out. Then you can proceed and launch the navigation mode. You'll have to exit the mapping mode, and once you launch the navigation mode, your job isn't done. Next step is to pick your default starting position. Pick a position that you can replicate. Pick something very characteristic on your map and place the robot there in a known orientation. And be sure that you can replicate that each time, because accuracy of that's going to be important for later. Once the robot is on the ground in a selected position, go to navigation and use the 2D position mode arrow to indicate the origin of the robot and also point the arrow in a direction that the robot is facing. The face of the robot is where the camera is, just if you don't know. Now, when you do that and when you place that arrow, nothing really will happen. You'll have to go back to the terminal window responsible for launching the this software and obtain the XZA coordinates. Now grab them or keep them safe and go to the folder containing the launch file. In the launch file, search the file for initial pose parameters and fill them accordingly with the data you grabbed from the terminal. Once you save this and reopen the launch file, it will assure that the software knows where the robot's supposed to be. Now make sure that the robot is in that position, and then you can actually get to the next exciting step, which is autonomous navigation. And this is where things got difficult again, because nothing from the documentation was working for me and I was clueless to what to do next. Thankfully, I received some support from Elephant Robotics that told me what should happen next. Now, by default, your software, your launch file will open in a single goal mode or single navigation goal mode, which means you won't be able to queue more of them. As soon as you're gonna place a single destination, then the robot will start moving. Now I was trying to put multiple ones and the robot didn't exactly know what to do, and this is where things got a little bit more confusing. For that, you'll have to download the plugin that enables that and add the extra panel and follow the instructions from official documentation for the robot. And this was the step that I was missing. So once I knew this, then I actually could move the robot from A to B autonomously without me giving its direction, and that was super exciting. At this point, if you come across the moment in which robot didn't know where to go, double check the initial position and double check the map is created correctly, because placing the robot inaccurately on the floor when your launch file is open might cause misalignment, and the robot might drive itself into a position in which it cannot resolve the movement and it will get stuck. So if something like that happened, just check those things again and try again, and it should be able to perform required movement. You'll notice that throughout the video I mentioned I got stuck a couple of times and I needed support from Elephant Robotics, and they were great at issuing me some help files and giving me support I needed. Even when support was sending additional files via email, those links were linked to completely different domains, and I was really confused how I supposed to find this information on my own, not knowing that it lies somewhere else. Included documentation had only a couple of steps to get everything going, and it didn't contain any troubleshooting or detailed information that would guide me through the process. And this is the biggest disadvantage of this platform. Hardware-wise, it's great, but the documentation is bare-bone and lacking. I understand that this robot has been on the market less than a year now, but with a documentation like that, it's not an easy platform to get started. It has a steep learning curve, and I wouldn't recommend it to anyone that's just getting started, because they're gonna get stuck so often and they're gonna constantly be looking for help until they probably get permanently discouraged and leave it on the side, just simply forgetting about it. Even the documentation sent to me about integrating the UltraArm with myAGV was very bare-bone, and honestly the programming one through each other contained like 3 lines of text, and I was left to my own. And yes, sooner or later I would figure everything out, but that will take time and it will take patience. And yes, robotics is difficult, but the difficulty should never be about finding the information, but using and utilizing the information to reach your goal. It is clear to me that Elephant Robotics should focus their time and attention on creating proper documentations and tutorials that would help you get started with a platform like that, because hardware-wise, it is simply fantastic and it allows you to do many things that I would never think you could do at home, because by default we don't simply have access to these complicated robots just off the shelves, and industrial solutions are simply beyond our wallets. Once they consolidate that knowledge into a very easy to read and watch documentation that you can just simply follow and learn along, the myAGV 2023 will be an exciting platform to jump in, learn, and use those skills to maybe secure a really interesting job in the future. I have a big positive sentiment to Elephant Robotics for a couple of reasons. First, they have a wide array of robotics arms, they're interested in the field, and they integrate solutions like Raspberry Pi, Jetson Nano, or M5 stack devices, which I personally adore. Hardware like this brings exciting possibilities to anyone that would like to learn more about robotics, get stuck in and challenge themselves and challenge their knowledge and possibly end up with a career moving forward. So these things aren't particularly expensive when you consider how much otherwise access to robots would cost you, so I'm all for it. I can't wait to see more documentation for it. I'm definitely going to return to this platform and play with it more. Until then, I'll be patiently waiting for the Elephant Robotics to finish the task and, well, drive the robot around a little bit more. If you're interested, I will link both the robotic arm and the platform in the description of this video. As for now, guys, I do not have a posting schedule, which means use your YouTube tools provided to your heart's content. There's a couple of social media links on the screen right now, so consider following me there if you want to start a conversation, and I'm definitely going to see you in the next video. Alright, take care. Bye. Robot, say bye-bye.